In this cases, we like to, this is the trick they're going to use. So there's a closed area like this. The integration of closed area like that. But because, of course, the other side is considered as insulation. There's no charges, there's no electrical field go out this way. The only electrical field going is this way, going this way. That's an E field. If you integration of this by it, so the area of this is A. So then you have E times A area. So that is equal to 1 over epsilon sub 0 Q. So the electrical field in it is equal to 1 over epsilon sub 0 Q divided by A. Now, as far as Q divided by A means one thing, is called charge per unit area. In which cases, if you charge per unit area is called the surface density. So that in that cases, the surface density for the charges is what? Is epsilon. So Q dot A is 1 over epsilon sub 0 sigma. So this is defined the electrical area. So suppose here is a separation for this is D. The separation of these two plates D, then the voltage changes. Delta V is equal to E times D. E times D. With this chances, then we have the capacitance, or is equal to like this. V is E times D, and there's a Q there. So we related to this. So here is Q, and here is E times D, in which case E is equal to 1 over epsilon sub 0 sigma times D. Okay, related with that. So in these cases, we have equal to Q. Q is equal to sigma A. Okay, so we do all that. So now we're missing one. Okay, so basically what we suppose get is equal to epsilon sub 0 times A divided by D.
We can cancel out the sigma.
So based on this information, this is called derivation. In these cases, when you want to make a capacitor, the only information you need is the D, the separation between the two plates, plus the material inside here, and the area. Then you define the capacitors. So there's come with different shape of capacitors. This come with the cylindrical shape. They can come with the plate shape. The cylindrical shape of capacitor is something like this, circular one. So that the circular charges and like this. This is more compact. You can wrap this around. So from this on, then depends on you connecting the capacitor. Capacitor have two-way for electrical connections. One of the connections of the capacitor connect together is called in series. Another capacitor connection is called in parallel. So that is one of the components. If you're lucky, M can ask this simple question, and usually they will. So in the section 20.8 is called the combination of capacitors. Combination of capacitors. So the combination of capacitors is serving a very good calculation problem for your test. Basically, it's not that much difference. When you study the resistors, the type of calculation are a little bit different. First, we're talking about capacitors in series first, in parallel. So capacitors in parallel. In parallel. So if you have a